Okay, so in class we worked on graphing exponential growth, but we didn't get to modeling. So on page 467, example 3, it says, in January of 1993, there are about 1,313,000 internet hosts. During the next 5 years, the number of hosts increased by about 100% per year. And it wants us to write a model giving the number h in millions of hosts t years after 1993. That's the first thing it wants us to do. Okay, so in our notes, we said that our model looks like y equals a times 1 plus r to the t power, all right? And a is my initial amount, and r is the percent, and t is the time. Y is what I get in the end. So for this particular problem, it said there were originally 1,313,000 hosts, and it said the rate was 100%, but I don't want to use percent. I want to turn that into a decimal. So I'd move it 2 to the left, which would just make it 1. And in our notes, it says we don't want to fill in for t when it asks us for a model. So even though they've given us some years, we're just continue to use it as t. The only thing we can clean up here is this 1 plus 1. So we have y equals 1,313,000 times 2 to the t power. Now, the reason why we can't go any further is because we talked about with power rules that unless they have the same exponent or if they have the same base, you can't take it any further. So this is my model. Now, if we look back at the problem, it says about how many hosts were there in 1996. Well, the study started in 1993. So how many years has passed? 3 years. Years is t. So they want to know when t equals 3, what's y? Well, I could work this out by hand, or I could use my graphing calculator. So in our notes we said, type the original in for y equals. My y equals key is right here. So I'm going to go to y equals. I want to make sure that nothing's in it. I also want to make sure that none of these plots are highlighted. Okay? And I'm going to type my model in for y equals. So 1,313,000 parentheses, 2 parentheses. Then I want to raise it. So remember, I'm going to use my caret key. And instead of t, we're going to use x. And x is right underneath mode. Okay? All right. So now we are going to actually put this t equals 3 in using my calculator. So we're going to hit second trace. Again, that was second trace. And that gets me to calculate. We want value here. You're probably not going to see anything graph right now, and I'll talk about that later. But you can see that it was kind of thinking up here in the corner, and now it's saying x equals, and it's blinking. It wants to know what x is. Remember, we're using 3. So we're going to type in 3, and we get 10,504,000. Remember, this was hosts. Y was hosts. So when I put t in for 3, when I put 3 in for t, and I cleaned that up, which I used my calculator to do that, I got 10,504,000. Okay? Now, the next question says to graph the model. We should be able to do that on our calculator too. In fact, we actually already did it. It's just that we can't see it. It's because your calculator has a specific window range that it's looking for. And so when we go to window, which is right here, it's going to talk about, the only thing we're going to pay attention to is my x min, x max, and y min, y max. Meaning, what's the very lowest x value, which remember that's time, what's the very highest x value? Well, we're talking about years. The very lowest years you could have would be 0 because we can't have negative years. And then the very highest value, it was in 1993 originally. So if you think about from then to now, that would be approximately 25 years. It doesn't have to be exact, just general. So same way with y. Y is talking about hosts. The very lowest hosts you could have is 0. The very highest host, well, We already have 10 million right now, and that was in 1996. I'm guessing the internet has expanded greatly, and so the hosts has expanded greatly as well. So in one of the other classes, we used 1 billion. That has 9 zeros. Now let's hit graph. Now we can see this nice curve, which we know exponential growth has. That's what it looks like. I don't expect you to graph a real life situation. I'm okay with you doing it on your calculator and looking at it. Okay? Now the reason why this is important is because now on C, it says use the graph to estimate the year when there were 30 million hosts. So now they're saying hosts is 30 million, and we don't know what the time is. Well, in our notes it said when you need to know t, you can type the original in, which we already have, into our y equals, and then you can type the second one in for y2, meaning I'm going to go back to my graphing calculator. I'm going to hit that y equals again. I'm going to leave my model in, but this time I'm going to put 30 million in for my y2. Because I want to see where those two are the same. I want to see where they intersect. So we're going to go to second, trace, and down to intersect. Now it's going to ask you some questions here, and you'll kind of see it come over mine. It's going to say first curve, hit enter. Second curve, hit enter. Guess, hit enter. I'm going to keep hitting enter until intersection comes up. Now my little cursor is down here, so it's kind of a little bit hard to read, but you can see when y is 30 million, x is 4.5. Sorry. And we know that study started in 1993, so 4.5 years later would be 1997. So that's how we can use a calculator to help us with those real life situations. Okay, now as far as the other example for compound interest, I want you to look at page 468, example 4. That walks you through how to sub in your numbers for compound interest. Remember, annually would be once a year, quarterly would be 4 times a year, daily would be 365 times in a year. And I told you guys, use your calculator as much as possible, meaning take 0.08 divided by 1, add 1, raise it to the first power, multiply by 1,000. Use order of operations to do that. Or if you're comfortable, just type it right in just like this. But don't round until the very end. Okay, good luck.